Hello everyone and welcome to another episode of Power Logic. So now this is the last problem of the 2022 AMC 12B, and let's get it started. We have a geometric problem. By the way, if you have any suggestions of content that you want me to record after this problem, then please leave it under the comment section. Now let's get it started with the problem. 4 regular hexagons surround a square with sides 1, each sharing an edge with the square, as shown in the figure below. The area of the resulted 12-sided outer non-convex polygon can be written as m times the square root of n plus p, where m, n, and p are integers and n is not divisible by the square of any prime, which just means that m root n plus p is the most simplified version. What is n plus p? So now let's jump into the problem. Now when we look at this shape, it seems that it's pretty symmetrical. Well, because you see that it's symmetric across this, and also the 2 lines here. It's actually pretty symmetrical. Okay, but we know how to find perhaps the area of a regular 12-hexagon, but what about this? These lengths are not uniform, and we cannot even just draw angles. So how are we gonna even deal with that problem? Now, when we look at this problem, when we look at this shape, it seems like if we draw a line like this, then it seems that we can actually make this shape to be an octagon, which will be actually a shape that's way nicer to deal with because we have a bunch of right angles and 45, 45, 90 right triangles, and that just seems to be better than this shape that seems to be really confusing. So now, if we just fill these lines, then we can see we actually got an octagon. And let's just try to find some side lengths. So now we know that the square has a side length 1. And we can also see that these 4 octagons are actually all with side length 1. Okay, but how are we going to proceed? Now we can see that this octagon is also symmetrical. So essentially, we can see that this side length also has length 1 and 1, 1, and 1. Now how are we gonna find this side length? That seems to be not really easy, right? However, let's just draw an altitude that goes through the entire octagon. And how are we gonna find this? Now we can see that if we just focus on one single hexagon like this, and we focus on the other hexagon like this, and we also look at the square but with these 2 hexagons as a whole, then let's just call this segment to be A, and this segment to be B, and this segment, just gonna use the same color, this segment to be C. Now we know that we want to find is A plus B plus C, because if we find the entire length, we can just subtract by 1 and divide by 2 to get each of these things right over here. So how are we gonna do that? Well, a plus b plus c is the entire length, but a plus b, we can actually find the value of a plus b. Well, a plus b, we have a hexagon with side length 1, and the value of a plus b is basically one of the diagonal that looks like this, which is perpendicular to 2 of the side lengths. And that side length would be not really hard to compute. We just imagine these to be 1, well, these are actually just 1 in this problem, and this angle is 120. So we just break out the law of cosines. A plus b is equal to the square root of 1 square plus 1 square minus 2 times 1 times 1 times, well, sine of 120 is actually negative 1/2, which is equal to the square root of 3. So essentially, a plus b is equal to the square root of 3. Now b plus c, well, b plus c is actually just the same as a plus b. So essentially, this expression is actually equivalent to saying that we want to find a plus b plus a, because c is actually equal to a since they're symmetrical. And now we're going to rewrite this as a plus b plus a minus a. Well, excuse me, minus b, which is equal to 2 times a plus b minus b. Well, you might be asking, why do you want to manipulate this expression into this kind of shape? Well, because we know b and we also know a plus b, but we don't know a, so we basically just want to express everything in terms of a plus b and b. Well, a plus b we just computed is equal to the square root of 3, so it's equal to 2 times square root of 3. And minus b, well, b is just equal to 1 because it's basically the side length of the square. So now, we know that a plus b plus c, which is the entire altitude of this octagon, to be 2 root 3 minus 1. So now, well, I don't know why is there 1 plus 1 plus 1 plus 1 equals 0 here, but just ignore that. And now we have this length. So what is going to be this height right over here? That is going to just be a plus b plus c minus 1 over 2, right? So essentially, let's just call this to be d. D is equal to a plus b plus c minus 1 over 2. And again, we're just utilizing the fact that this shape is so symmetrical. So therefore, we know that the length in red and the length in blue are congruent. A plus b plus c minus 1 over 2, we can just easily compute it to be 2 root 3 minus 1 over 2, which simplifies to square root of 3 minus 1. Okay, so we know that this is square root of 3 minus 1. Okay, now what to do next? Well, we know that if we draw a triangle, then this triangle is actually 45, 45, and 90. Well, because we know that this angle is 120 degrees. And we also know this angle because this angle must be 150 degrees. So after we know that this angle is 150 degrees, then this is 15. would just simply be this to be 45. And that's just an isosceles right triangle. So now we're gonna find that the area desired is actually equal to the area of the octagon. But we have to subtract the area of these 4 tiny triangles, because remember we added these 4 triangles to form the octagon, right? So we're gonna subtract these triangles. So minus 4 times the area of triangles. So, okay, what is the area of the octagon? Well, we know that what are these 4 side lengths. Oh, this is root 3 minus 1, 3 minus 1. So essentially we have that the area is just gonna be area of the octagon. That's just gonna be 4 times the area of the small isosceles right triangle, which is 4 times root 3 minus 1 squared over 2. Plus, we also have 4 rectangles, which is just these rectangles, right? These rectangles, that has 1 times square root of 3 minus 1, because 1 is the height and root 3 minus 1 is the length. Now we have to plus the middle square, which is just simply 1 square. So we're just going to evaluate this, being 2 times 4 minus 2 root 3 plus 4 root 3 minus 4 plus 1. To 8 minus 4 root 3 plus 4 root 3 minus 4 plus 1. And aha! The radical terms all cancel out, so we're just left with a 5. Okay, but we still want to find this area of the 4 triangles. So how are we gonna do that? Well, since we found that this is 150 degrees, and we also found that this sinus, well, this sinus is basically root 3 minus 1 times the square root of 2, which is equal to root 6 minus root 2. Now, can we find these individual lengths? And if we found these individual lengths, then we can simply just find the area by using the formula 1/2 times AB sine C. So now, we're just gonna drop an altitude here. Now this side length is just gonna be root 6 minus root 2 over 2. And that is actually the, let's just call this to be S. That is actually equal to S times sine of 75 degrees. Right? Because when we look at this triangle, this is actually the opposite. Opposite of hypotenuse is equal to sine. So now, so essentially we just have S is equal to root 6 minus root 2 over 2 over 2 sine 75 degrees. Alright, this is actually just the quantity that we have. Now let's just not evaluate this right away. So what we want is 1/2 times s squared sine of 150 degrees. Because that's the area that we want to find. We don't want to find the individual side, we want to find the area. So just leaving the answer, just leaving the side as it is, might simplify some of our calculations. So it's going to be 1/2 times root 6 minus root 2 square over 4 sine square of 75 degrees. Now, times sine of 150 degrees. What is that? That is equal to 1/8. Times, well, top is going to be 8 minus 4 root 3 over, well, actually, we probably just still have to calculate that. Well, we know that sine of 75 is actually pretty large, so it's actually root minus root 2 square over, well, root 6 plus root 2 over 4 square times sine of 150. Well, don't forget the trigonometric value, but it's simply just 1/2. Now this just gives us 1 over 16 times, because this 4 square moves onto the top, times 16 times root 6 minus root 2 over root 6 plus root 2 entire thing square. Now that is just equal to, well, root 6 minus root 2 square over root 6 square minus root 2 square. Well, that is basically what I did by simplifying the fraction over here. Which is equal to 8 minus 4 root 3 over 4, which gives us 2 minus the square root of 3. Let me just see if I did any mistake in my calculations. Oh, wait, this entire thing square. And that would simply just give you 7 minus 4 times the square root of 3. But that is actually the area of one single triangle, but we want 4 of these triangles. That would actually be 4 times 7 minus 4 root 3, 28 minus 16 square root of 3. Okay, so remember what we want to find. What we want to find is the the area of the octagon minus 4 times the area of the triangle. So answer, which is simply 5 minus 28 minus 16 root 3, which is equal to 16 root 3 minus 23. So that is finally our answer, and our answer is m root n plus p, which there are integers. So it's not restricted to positive integers, so we know that we are good here. So n plus p is just going to be equal to 16 plus 3 minus 23, just equal to negative 4, which gives us our answer choice B, finally. Thank you for watching this episode, and I hope you have a great day, and see you next time. Hope you enjoy this video.